section, we are discussing about the sign convention in case of a spherical mirror. Actually, the sign convention is used for the proper using of mirror formula. That is, the relationship between object distance, image distance, and focal length for a spherical mirror is given as the mirror formula, that is 1 by f equal to 1 by u plus 1 by v. For the proper usage of this formula or the proper validation of this formula, we have to use this sign convention, Cartesian sign convention or new Cartesian sign convention. Sometimes it is known as in these ways also. For the proper validation of the mirror formula, we have to assign certain values are negative and certain values are positive in respective situations. And that particular situations are actually mentioned or actually considering as the sign convention. While measuring the or while taking the object distance, image distance, focal length, object height and image height, we have to assign the sign also. And whenever and which situation we have to consider certain quantities are positive and certain quantities are negative, that is given by the points of this sign convention. It consists of mainly 4 points, and the first point is always we have to consider the object on the left side of the mirror. Whether it is a concave mirror or convex mirror, we have to consider the object on the left side of the mirror. Then the second point is pole is considered as the origin of all measurements. Pole is considered as the origin of measurement. And the third point, all the distances measured parallel to the principal axis on the left side of the mirror is negative and those on the right side of the mirror is positive. And the fourth point is all the distances measured perpendicular to the principal axis on its upper side is positive and those on the lower side of the principal axis is negative. The measurements taking parallel to principal axis are object distance, image distance and focal length. If these distances are measured on the left side, then we have to assign negative sign, and if these distances are measured on the right side of the mirror, we have to assign it as positive. And the distances measured perpendicular to principal axis are height of object and height of image. If these heights are measured above the principal axis, then that should be positive values, and if these heights are measured below the principal axis, then we have to assign it as negative. This is the sign convention. The sign convention in case of the spherical mirror is very similar to the graphical system. That is, while drawing a particular graph, x-axis and y-axis we have to consider, and the point of intersection of this x and y-axis are considered as the origin. In the same way, here instead of x and y-axis, we have to consider principal axis as the x-axis and the mirror. It may be a concave mirror or a convex mirror, and the mirror we have to consider as the y-axis. And what is the need of this sign convention, or what happens when we are violating this sign convention? When we are violating this sign convention, the mirror formula becomes an invalid one. That means the relationship between object distance, image distance and focal length will not be satisfied. With a simple example, we can understood what happens if we are violating this sign convention. Just we are considering an ad or advertisement of a detergent. With the help of three image frames, their message will be displayed. Almost all the advertisement of detergent first visualize a beautiful lady with a dirty cloth. Then a second image, that lady dipping that dirty cloth in a bucket of water in which the particular detergent is dissolved. Then in the third frame, when that lady taking out that dirty cloth, it becomes a perfect white one. This is a proper order or the sequence of that advertisement. Then just you imagine we are violating the visual order of this advertisement. That means just we seeing this ad in a reverse manner. Then what will happen? Just you imagine. The same thing happens in case of this optics when we are violating this sign convention.